Well, I was trying to be an artist here. Unfortunately, it seems like I'm a chemist. So let me do chemistry then. So what you see here at the top, of course, it's a rock. So what you'll recognize about a rock in terms of its nature is that, of course, it is a solid. That is what we say as chemists. To say, well, a rock is a solid. There are many other things, of course, which are solid in nature. The chair you are sitting at, it's solid in nature. The fridge that's buzzing in your room, it's solid in nature. So of course we can be able to identify solid things. But now we also have water. Water is a liquid. Well, as you advance in your knowledge, of course, in chemistry, you will learn that, well, when we talk about liquids and gases, we usually talk about things called fluids. So liquids and gases are called fluids. We will talk about why they are called such. Right now. So it means water in nature, it's a liquid. Well, I'm going somewhere with this, so I hope. Well, there I am, of course. You can see how handsome I am there. I tried to draw myself there. So, well, in order for me to survive, of course, there's something that must happen. It's a must. It's a necessity. So, right now. And that is, of course, to get what? To get oxygen from the atmosphere. So the oxygen comes into my lungs and I'm able to breathe. So that oxygen that I'm breathing, it also has a state which we call, well, a gas. So, right now, grade 11, so this is for you. Well, where we are is, of course, going to be whereby we talk about the issue around gases. So you can see that in actual fact, we have three states: solids, liquids, and gases. Well, some chemists argue that we have more. Well, we'll talk about that one day, perhaps when I won Lotto. So, we can see that we are having three states of matter that are common at this time and moment, and that is solids, liquids, and of course, gases. Now, we are going to talk about the kinetic molecular theory. So the kinetic molecular theory then will try to do what? It will try to explain to us what are solids, what are liquids, and what are gases, which is what in actual fact we are more interested in. So the learning objectives, of course, today includes us understanding what are the differences between the real gases versus the ideal gases. So that's what we are going to talk of and about. Right now. So let me tell you something. Chemistry is the study of composition of matter. It is the study of structure of matter at a macroscopic level, microscopic level, and symbolic level. So, do you remember when I said, hey, the rock in what? So when I was talking about the rock there, we couldn't see what was happening internally. We couldn't see what was happening at a microscopic level. At a macroscopic level, we see something dangerous, something var. Whatever they say, they're Africans, So at a microscopic level, this is definitely what is happening here. So for solids, we have particles vibrating at a fixed position. So that is what is happening then when you talk about solids. So this is solids, or these are solids in nature. So now let us look at liquids and how they look. Look at liquids and how beautiful they are. So the difference then between the solids and the liquids is that the liquids, of course, have these spaces between them. So right now, I hope you can see the spaces between the particles, unlike solids whereby yes. So of course, when you go to gases, look at gases in so look at what is happening to gases. And grade 11s, I said we're going to focus more on these gases. But however, there are quite a few terms or concepts that we are going to talk of and about in this topic before we talk about a lot of things. Do you remember that I said we have solids, liquids, and of course gases? We are going to be interested in gases only, specifically like why. That is because, of course, we have about three of chemists who tried to explain, of course, to us the gas laws and how gases operate. That's how interesting they are. So Halala right now. So for now, well, just to remind ourselves of the kinetic molecular theory, let us go back to solids. I don't know what I've done here, but it's weird whatever I did. We are back to where we are supposed to be. So now we are having these particles. Remember, we call these whatever, we call them particles. They are vibrating about a fixed point. So there is something very interesting that we can introduce here that can make these two act weird. Think of ice. Over ice from the fridge, put it in a pot, try to boil it and see what's going to happen. So what you see here is that we are having particles for ice. Think of ice as a solid. Ice is a solid, of course, why not? So at this time of moment it's an ice. So let's see what is going to happen if I increase the temperature. Again, we are chemists, and we know South Africa. Here we are now in United States of America, Denver, University of Colorado. That is why we are able to perform such beautiful experiments. Right now. So we want to understand a physical quantity here called temperature. So let's see what happens when we increase the temperature to liquids. I just want you to see what happens and take key things into consideration. Please take the following into consideration. Can you see something about the particles? Right now. So the particles collide with each other. The particles collide with the surface. Is it called surface? Yeah, the surface, of course, of the container. So that is what is happening here. The temperature is still being increased at this time and momentum. So right now. So what you recognize about these particles is that they are colliding. So you must know what is that collision, and you must know that in relation to pressure. We'll talk about that. Let's not rush as such. So it was a solid. Look at what has happened now. It is thanks to temperature. So there are 4 things that I want you to take into consideration for now when it comes to this topic. Let us understand what temperature does to particles. We are going to look at that specifically to gases to see what does temperature do to gases. We are going to explore that. We are going to also explore the volume. We are going to explore the number of moles. What else are we going to explore? We are going to explore the volume. I will edit that and put it there. So that is what is happening here. So we are going to explore the importance of those, and they are going to give us what we call gas laws. Right now. Look at gases. Look at how beautiful they are. So now remember we said that this is the formula that we are going to survive with and by from this topic. P V is equals N R T. We just started like that for now, and we try to exploit. Let's see how could we exploit. Perhaps first let's explore pressure. Well, P for pressure. Simple as that. So do you remember that I said pay careful attention to something there, which was of course the collisions between the particles themselves, and the collisions between the particles and the surfaces of the container. So as those collisions happen, then we can talk about pressure. That's how pressure comes in this study. Then we have volume. Well, if you recall from what we had there, we had a bit of a container. Well, it was a bit enclosed. And what happened? Well, I'm Donald Trump, or I'm Mr. Donald Trump. Sorry for that. Now, what I'm trying to say is that, of course, there was some bit of volume, specifically for what we call real gases. There was a specific volume, a particular volume, of course, that is set for this particular gas or gases. So that's how we got to talk about what? That's how we got to talk about the volume then in this area of study, real and ideal gases. Well, do you remember or recall quantitative aspects of chemical change, grade 10? you have that Shandis. So Mfanaboso, you were talking about quantitative aspects of chemical change, whereby of course we were talking about the number of moles and things like that. So that is going to be very important, of course, in this study then of real and ideal gases. I hope you are able to find the number of moles. Satoba wiki Mfanaboso right now. Maybe you might be scared about this guy here, R. Maybe that's my name. Why not? So R, of course, unfortunately, is just a constant. You need not to worry much about it. You are given. It's always given to you in boss. So, of course, in your what sheet, they call it something like that. So now the other important thing that is, of course, worth consideration then in this regard is this guy here, the temperature. Well, in temperature, we are going to realize that in actual fact, in this topic, we are going to talk about temperature in relation to what we call Kelvin. Well, now how do we talk about Kelvin and all that? Well, what we just do, we just say, okay, let us add 273 kelvins. Today it's 15 degrees Celsius. For now, let's say that today is 15 degrees Celsius. So to go to kelvins, we'll just add 273. We need not to complicate things. You just have to understand it as is.